I set out to build the world's smallest home lab, which this clearly isn't, but it's still pretty freaking small, right? I wanted to create a super compact home lab setup complete with a virtualization host, mass storage NAS, high-speed networking, a UPS, and remote access through a KVM. The goal wasn't to be the smallest, the most powerful, or the cheapest, but rather a combination of those, and I think we did it. Let's take a look. Now, the heart of most people's home labs is going to be some kind of NAS to hold all their data, media, and back up their machines. It's also super common that the same machine doubles as their virtualization host for things like VMs, Docker containers, and other apps, but we didn't do that here. I wanted to separate the two for a few reasons. One is that I like having my storage separately in the event that either my virtualization host or storage host needs to be updated or something, I don't have to take down the other one. Another is because I actually wanted to use the Zima board too, which is perfect for a compact NAS, but I wanted a bit more power for virtualization and other apps, and this GMKtec unit checks a lot of those boxes, as you'll see in a bit. So the NAS, like I said, is going to be this Zima board too, along with some of their accessories like the dual drive bay mount, PCIe extender, and this fan mount that I designed. The Zima board 2 is pretty unique here and honestly a perfect fit for what we're trying to do because it's got a low power CPU in the N150, it's got a decent amount of RAM at 16 gigabytes, and it's got dual 2.5 gig networking ports, 2 SATA ports, and PCIe expansion all in this tiny form factor. The accessories here are just going to make turning this into a proper NAS easier. And I'm using two 12 terabyte hard drives in this setup as a mirror in Zima OS to give me around 10 terabytes of usable space. For PCI expansion, I'm just going with an NVMe drive to give me some faster storage to share. You could honestly put whatever you want in here, like faster networking, an HBA for even more storage expansion, or maybe even a GPU. It's a pretty versatile device and comes loaded with Zima OS, but you're free to use whatever software you want. For simplicity and just to try it out a bit more, I'll be keeping Zima OS on here. After setting up my mirrored storage pool, all we had to do was set up the share to officially make this a NAS. Luckily, setting up a share in Zima OS is super easy and something I discussed in one of my last videos, so I won't spend too long here. Basically, we're just going to create a folder for our media and one for a general share. And sharing them across the network is as simple as right-clicking them and clicking share. From there, you'll be able to set whatever permissions you want and connect to them across your network. In terms of a pure, straightforward NAS, that's honestly it. You could go into backups and stuff, but for the scope of this video, that's all we really need to do. I tested a share from the hard disk array as well as my NVMe drive, and both saw speeds right at 2.5 gigabits per second, which is what you want to see given that our 2.5 gig networking was expected to be our bottleneck. Next, we have our virtualization host, and this could be such a wide range of different hardware and software options. But this right here is the GMKtec K15, and again, for my use case, I think it's perfect. With an Intel Core Ultra 125U, we get 12 cores, 14 threads, which is a nice combination of raw power and efficiency. We also get 32 gigabytes of RAM, so quite a bit for virtual machines and other apps. And we also get 3 NVMe slots at PCIe Gen 3x4 speeds. And just like the Zima board, we also get dual 2.5 gig networking, which for most people will be plenty. What I really like about this device though is that I think it's the most affordable mini PC you can get with an Oculink port. This allows for PCIe expansion using external Oculink dock or specialized cards. And I've used Oculink in quite a few projects, and it's a solid way to add some features to your setup. The fact that both of our devices here have some sort of PCIe expansion is pretty sweet. Now for software here, it comes loaded with Windows 11, which I used to run some Geekbench 6 tests, and they're about what you'd expect for an upper middle class mini PC. It's not going to blow you away, but with this much power in this low of a TDP, it's kind of what I wanted in a home lab. For a proper virtualization host, you could certainly leave Windows on here, as much as all the neckbeards will tell you otherwise. Windows has the ability to run VMs with Hyper-V or something like VirtualBox, and with WSL2 and Docker Desktop, spinning up apps is pretty easy too. But I know you true turbo nerds think Windows is cringe, so I put something a bit more appropriate on here. Proxmox. Proxmox is, in my opinion, the best pure virtualization server operating system, but you're free to argue down in the comments. I actually ended up putting in another NVMe drive so that I could have two to run a boot mirror, which is great in the event that one fails, my server will still run. From here, I could spin up some Linux VMs for testing distros, a Windows VM to keep my cringe low-key, some LXC containers for apps, or even spin up a dedicated Docker virtual machine. For a device like this, it would make a fantastic media server since you get Intel's Arc graphics and their awesome transcoders. Then you have plenty of horsepower left to run all the cool self-hosted apps you can find, like Image for photo management, Tailscale for a proper VPN, AMP for hosting some game servers, and while you can do some AI inference on here to get something a bit more usable, you can utilize that Oculink port with a dock and plug in a GPU. Yes, that adds to the footprint and the power envelope, but like AI, right? One thing I do need to address is that while we've established this as our virtualization host and the Zima board as our NAS, that doesn't mean we can't run anything on the Zima board. You could easily host a good bit of stuff over here, even a media server, since the N150 gets built-in transcoders as well. Personally, I'd probably keep it as pure storage, maybe run Nextcloud on there or something, but yeah, you don't have to do exactly what I do. So the world is your oyster here, but the one thing we need to make sure that we do is connect our virtualization host to our NAS so that we can actually utilize that storage. This is where this super compact little switch comes into play. Kind of. I was looking up 2.5 gig switches since both of our devices use 2.5 gig and came across this thing. It's a 6-port unmanaged switch from Sodola with 4 2.5 gig RJ45 ports and 2 10 gig SFP Plus ports for $36. Yeah, I am aware that this is just a mass-produced Chinese switch that probably gets branded under a zillion different names, but for that price, I had to try it out. I mean, it certainly feels like a $40 switch being super light, but at least the case feels somewhat decent with some nice metal, I guess. With both devices connected to each other via the switch, we were damn near saturating that 2.5 gig connection, which is all we could really ask for. Now, we could just leave it at that with the connection going directly through the switch, but I wanted to take it a step further. In addition to that, I just connected the extra port on each device directly to each other to give a direct communication path to each other without having to worry about any bottlenecking on the switch from additional devices down the line. That just involves me configuring the other interface in Zima OS as a static instead of DHCP and giving it whatever private IP we want, then set the subnet to the 31 range, which essentially just means 2 devices. Similarly, on our virtualization host, we are going to go into the Proxmox networking setup and create another Linux bridge with an IP address just 1 tick up from the one on our Zima board, and again, 31 subnet. Then make sure the bridge is linked to the other interface, apply the configurations, and boom, we can have our 2 devices talking directly to each other. We can even add our Zima OS shares in Proxmox using those new IPs. Pretty neat, right? I use the share directory as a catch-all to handle everything like disk images, ISOs, containers, and most importantly, backups. Now we can set up all of our VMs and containers to be backed up directly to our Zima board, which is another good reason to have our virtualization host and NAS separate from each other. The last actual piece of hardware here is our UPS. This is the same Triplite one that I used on one of my mini rack builds since it was pretty much the only one that fit, which means it's actually a pretty nice form factor for a compact desktop setup. It's only 600 volt amperes, 300 watts, which is rated for 5 minutes at half load. Not amazing, but a UPS isn't really designed to run your stuff extensively. It's for protecting against power trips and to give you just enough time to gracefully shut down everything during a major outage. Plus, we aren't using anywhere near 150 watts here. With everything running a minimal workload, we were only pulling around 50 watts, which for what we have here isn't really bad. Could we get it lower? Probably. Like, we could run everything on the Zima board or undervolt everything and have it run a more conservative power curve, but 50 watts for all this is pretty good. Now, the thing that I added last minute was a remote KVM, and today you can find all kinds of compact options from a bunch of different brands. I think GL-iNet makes the best options at the moment, but for the most part, they all do the same thing. Allow you to connect to your device and control it via a web browser. I feel like I've gotten so many questions like,
Brett, why not just use RDP?
Okay, yeah, you can use a software-based solution for remote control, but what happens if the software crashes or you want to access your devices at the BIOS level? Checkmate, atheists. Anyways, that's our compact little home lab. I think it's awesome, and while it's not perfect, I think it checks the use cases of like 99% of people out there. But what do you think? Let me know down in the comments if this is something that you do or what you do differently. But that's it. Drop a like if you liked it and subscribe if you want to see more home lab stuff. So we've got some cool little projects coming down the pipeline. I want to give a huge shout out to my YouTube members and my Patreons. You guys are my super compact home lab that satisfies this slogan. It's not about the size, it's about how you use it. Y'all are the best. But if you're still watching, you're a 42U server rack. Thank you so much, and I'll see you in the next one.